Okay, Bismillahirrahmanirrahim. So we have to talk about the applications of differentiation today. I will not be talking about all of the applications, but just one of the applications of differentiation today. That is the dy by dx. This dy by dx is actually the gradient of the curve. Gradient of the curve, we call this, or you also say that this is gradient of the tangent on the curve. Okay, so in general this is the gradient of the curve. Let me give you an example. Guys, look at this equation, y equal to 2x plus 5. So clearly it's a straight line, I mean equation, a linear equation. So what's the gradient of this line? Hmm? Can you tell me? Hmm? Anyone? What is the gradient of this line?
2.
Yeah, that is 2. Because if you see that, if you relate this with the y equal to mx plus c, this is the slope intercept form. So this 2 is the gradient here. The gradient of this line is 2. And you see there is an interesting thing over here, that if I differentiate this with respect to x, what should I get? This is dy by dx, and that is equal to 2. So you see, you're getting the same this 2 over here as its derivative. So whenever you differentiate the equation of a line, or in general equation of a curve, you get the gradient of that curve. Now, for instance, you have a quadratic equation here. This is y is equal to, let's say this is, I'm taking this x squared plus, let me just take x squared, okay? So that I can tell you that how this is, like, let me draw this y equal to x squared over here. This doesn't look like a perfect parabola, but you can excuse me for that, okay? Now, this should be something like this on this side. Okay, so if this is your y is equal to x squared, so what is dy by dx? Dy by dx is going to be
2x.
2x. Okay. Now, this is the gradient of the curve in general. Okay. So, you people remember that whenever you have to determine the gradient of the curve at a certain point, you have to draw a tangent there. Okay. So, for instance, if I draw a tangent here, let's say at this point here, okay, it looks like this. And if I draw it here, it might look like this. So suppose you have x equal to 2 over here, and you have x equal to minus 2 over here, okay? So you have to put x into this. So you see that at x equal to 2, m is going to be 2 into 2, and that will be equal to 4. So, and similarly at x equal to minus 2, so you will see that this m would be equal to 2 into minus 2, and that is going to be minus 4. You can clearly see that this is an upward, an increasing, a rising line over here. So this is justified that this its gradient should be positive, and this is decreasing line going downwards. Okay, so its gradient has to be negative. So you see that the gradient is negative over here. Imagine this x-axis being a tangent onto this curve as well. Okay, so this is a horizontal line. What is the gradient of a horizontal line, guys? What is the gradient of this line?
Yeah.
0. So if, this point is 0 comma 0 over here. So if you put x equal to 0 into this derivative here, you will get at x equal to 0, your m is equal to 0. So now you must have a belief that the gradient, the dy by dx, gives you the gradient of the curve, or gradient of the tangent at a certain point on that curve. Okay, so you need to have the x coordinate of that point where you want to draw the tangent, okay, or you want to determine the gradient. So I'll be taking you guys back to this exercise. Achha, There's one thing that you people get the gradient of the curve through this derivative. And then typically you will have a question that, okay, if this point is 2 comma 4, and then you will have to write down the equation of this tangent. So you remember you have learned a quicker way of writing the equation of a line, that is y minus y1, that is equal to m into x minus x1. Okay. So I'll be telling you about this in the next segment of this lesson.